Hi again everyone, Dr. Tom McNamara here again for our course in Prep for College Math. In this video I would like to discuss the CHIP model for multiplication. So remember, part of the purpose of our course is to make math make sense. So we want to understand why the rules that we have learned to do computations work the way they do. And I think the CHIP model can help us in a lot of ways. But before we get to the CHIP model, let's just talk about what multiplication actually is. And one of the best ways, I think, to think about multiplication, so multiplication as repeated addition. Okay, multiplication as repeated addition. So for example, 5 times 3, the way to think about that is 5 copies of 3. Okay, 5 copies of 3. So 3 plus 3 plus 3 plus 3 plus 3. Now of course these copies of 3 are considered in total. Okay, so the 5 is coming into play by the fact that we have 1, 2, 3, 4, 5 3's. All right, and of course if we actually do the total, we have 3, 6, 9, 12, 15. And of course we remember from our multiplication table 3 times 5, or in this case 5 times 3 is 15. Okay, so keep that multiplication as repeated addition in mind as we work through some problems in the CHIP model. So here's our first problem that I will illustrate with the CHIP model. Okay, 28 times 3. Now, you might remember from a previous video that when we're doing the CHIP model, we have these trays. Tens and ones. If I have larger numbers, I may need to put in a hundreds tray or even a thousands tray. But I think we should be okay with this for this problem. Okay, so 28 times 3. Okay, so I'm thinking 3 copies of 28. 3 copies of 28. So 28, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Let me put this one down here like this. Okay, so that's 1 copy of 28. 2 copies of 28. And finally, 3 copies of 28. So what I've done is I have loaded this number, 28, into the CHIP model 3 times. All right. Now, you might remember from a previous video that when we are using the CHIP model, we are only allowed to have 9 chips in any of the trays. So over here, I'm good. I've got 6 chips in the tens tray, so that's fine. Over here, I'm in a little bit of trouble because I've got 4, 8, 12, 16, 20, 24 chips in the ones tray. So I can't write a 24 in the ones place for my answer. The biggest thing I can do is a 9, okay? So you might remember from the video where we did addition with the CHIP model, what we do if we run into a scenario like this where we have too many chips in one tray is we take those and trade them in for another chip over here, okay? And we do that in bundles of 10. So there's 10 chips right there. Okay, those are gone. Give me a new chip in the tens tray. Okay, I've made some progress, but there's still more work to do because this is 4, 8, 12, 14. I've still got 14 chips in the ones tray. That's still too many. So I'm going to trade in another 10 chips. These guys go away as well. Give me one more in the tens tray. Now I'm good. I have 4 chips here. And let me make sure I didn't cause any problems over here. I had 6. I added 2 more, so that is 8. Okay, so 28 times 3 is 84. Okay, now you might remember when you learned the pencil and paper algorithm for this, how carrying works in multiplication. So firstly we do 3 times 8, which is 24, as we were seeing over here. So we put the 4 down here, we carry the 2. Then we do 2 times 3, which is 6, and then add the 2, which is 8. Okay? So the standard pencil and paper algorithm is illustrated by what we're seeing happen in the chip model. We end up having to bring 2 chips over here because we had 24 chips over here, so it gives us 2 extra groups of 10 to bring over. That's what this 2 up here is indicating in the standard pencil and paper algorithm. We're bringing 2 things over to the tens column. That overflowed the ones column when we did our multiplication. Okay. Let me do one more here. What do I want to do? I think I want to do something like this. $68 times 2. Okay, I'll do it in the chip model as well. Notice here, I am bringing the hundreds tray into the mix. I think I'm going to need that, but let's see. We'll follow the same procedure. We are going to load this number, 68, into the chip model 2 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. That's one copy of 68. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So we can see once again, I have overflowed my trays. In my ones tray, looks like I have 4, 8, 12, 16. I've got 16 chips in the ones tray. I cannot keep 16 chips in the ones tray. I can only do a maximum of 9, so I'm going to have to do some rebundling. Alright, as before, I'm going to take 10. Those are gone. I trade them in for 1 new chip over here. Maybe I'll put her down here. Trade them in for 1 new chip in the tens tray. Now I'm good here. I've got 1, 2, 3, 4, 5, 6. So we can keep that. Now we turn our attention to the tens tray. Alright? And we can see I've got 6, 12, 13. Once again, no good. I can have a maximum of 9. So what I'll do is I will take 10 of these. These are gone. We trade them in for 1 chip over here in the next column over. In this case, the hundreds. We trade those in for 1. And we can see our result. 136. Okay? So answer down here being 136. Okay? Now if we go and compare this to the standard pencil and paper algorithm, we can see where the carrying and stuff comes from. 2 times 8, we know that is 16. We write down the 6, carry the 1. 2 times 6 is 12 plus the 1. Okay, so kind of important that you remember how this works. You multiply these, but you add that. Okay, whatever is carried over gets added after you do the multiplying. So 6 times 2 is 12, plus the 1 gives us 13, okay? So I can kind of carry that, you can see that 1 is actually being carried over to the hundreds place. From the 13 that we had here, we're bringing that 1 over there, giving us 136, okay? The chip model helping us understand why carrying works the way it does when we have multiplication. So a handy little way to understand things.